Alright, hey guys, so you've clicked on this YouTube link, and now you are looking at how to do Test 1, Problem 1, our Pelican diving into the water question. And I'm Alex Plager, here to walk you through the steps of doing that. So, Problem 1 was a pelican diving into water at a known angle, at a known speed. And so, what we need to do in order to tackle this problem is write code in order to predict the path of the pelican as it moves through the water, through its dive. So the information that we have known to us is the initial speed of the pelican, which is 15 meters per second, the angle at which the pelican enters the water, being 20 degrees from the vertical, and a way to derive the drag force that the water exerts on the pelican, which is proportional to the speed of the pelican cubed. And our task in order to solve this problem is to fill in the code to answer this question. Alright, so here we've got all of our code that we need to build our answer to the problem. So our known information we're starting out with is the known mass of the pelican, 15 kilograms, and its initial position being that of the origin. So our first step is to find the initial velocity of the pelican. Well, we know that if you multiply the speed of the pelican times the respective sine and cosine of the angle, you can derive the components of each velocity, or each direction of velocity. So we can go ahead and do that here, and then we get our initial velocity. Then the next step that we need to do here is to add the necessary code in order to update the position of the pelican, which we'll essentially do by deriving all of the forces acting on the pelican and using that to calculate its next position through Newton's second law. So first off, let's go ahead and record the force of the Earth acting on the pelican, which is going to be essentially just in the negative y direction, the gravity force. So we can give that by multiplying g, which we have set earlier in the code, times the mass of the pelican to get the gravity force. And the next thing is we also want to calculate the drag force, which we know to be proportional to the speed of the pelican cubed. And since it's in the negative direction, we're going to do negative v times the velocity of the pelican, so that we have a direction for this vector to go into. Then we're going to multiply this by the magnitude of this velocity in order to cube the actual value twice. Not cube it twice, but multiply it twice, just to be clear there. And so these are the only two forces acting on the pelican, so we know our net force to be force of drag plus force of the Earth on the pelican. So now that we have our net force, we can update the position of the pelican's velocity by reassigning the velocity value to the old one plus our Newton's second law. You can rearrange the equation F equals ma into A equals F over m. So we're going to have F net divided by the mass of the pelican, and we're also going to multiply that value times delta t in order to update it over time. And the same goes for the position of the pelican dot position. I'm going to set that equal to the previous value of position in the while loop. And we're going to add it to the change in position, which is pelican's velocity times time. And so we finish the code by adding in the update to the position of the pelican, or the time, you do the time step, and you just then print the position of the pelican. And there we have it. This is the full code and everything you needed to get full credit on question 1 of test 1 in Physics 2211.